Okay, so we're doing more combinations, breathtakingly hard ones this time. A class consists of 5 girls and 7 boys, so we have our great big group, which contains 5 girls and 7 boys. And from that, we're supposed to pick a committee that consists of 2 girls and 3 boys. If there are no restrictions other than that, how many ways can we do this committee? Well, there are 5 girls, we have to grab 2 of those. And there are 7 boys, we have to grab 3 of those. How many ways can we do that? 5, combination 2, there are 10 ways to pick the girls. And 7C3. There are 35 ways to pick the boys. So there are 350 committees from what they've said so far. Now, Johnny has to be on the committee. That changes our selection groups. This isn't the only way to do it, but it's one way to do it. You can say, now my class looks like this. I have 5 girls, and I have 6 boys, and then I have 1 extra special boy named Johnny. And the selections are going to be from the 5 girls, you get to pick 2. From the 6 boys, you get to pick 2. And from the 1 Johnny, you get to pick 1. Okay? We get our total of 3 boys. It's just one of them that's a special boy and 2 of them are regular boys. And from the 5 girls, you get your 2. So we still have the right gender totals like they set up above. It's just what you're allowed to pick from has changed a little bit. It's here's Johnny, take him. And then from all the boys who aren't Johnny, take 2 more. So you have a total of 3 boys. And then this. So 5C2 is still 10. Nothing's changed on the girls' side. 6C2 is 15. There's 15 ways to pick the regular boys. And 1C1, there's only one way to pick Johnny, so that doesn't really affect anything. 10 times 15 is 150 committees that have Johnny on them. Now, the twins Peter and Paul can't both be on the committee. These are both boys, so again it's going to be changing the boys' total. And so let's change our breakdown a little bit. I assume that they don't care about Johnny anymore in this example, so it's just about the twins. Here's what we've got. We still have 5 girls. We had 7 boys, but now what we have is 5 boys, and then we have the 2 Peter and Paul the Peter and Paul twins. I'm counting them as a separate group because there's a special restriction about them. And our numbers go from the girls, we still need 2. And, well, here we get a bit of a problem. Can't both be on the committee could mean a couple of things. It could mean neither of them is on the committee. If neither of them is on there, then you can say, nope, they're not both on. And if one of them is on, that would be okay as well. Either one of these ways that we are covered for not having both. The trouble is, if there are, let me change colors for this. If neither of the twins is on there, then we need 3 regular boys. If one of the twins is on there, then that's one of our boys and we only get 2 more. So guess what? We get to work this twice. We have to cover those 2 requirements separately. It's too much to do all at once. Or at least it's too much to do all at once for me. So I'm going to do 1 line for no twins and a separate line for 1 twin. And we'll add them up at the end. If there are no twins, then there are 5 girls, get 2 of them. There are 5 regular boys, take 3 of them. And if you wanted, you could say there are 2 twins, don't take either of them. This comes out to 1, so it's kind of pointless to put it in. But that's the number of committees that have no twins at all on them. 5C2 is 10. We knew that already. And 5C3 is 10 again. So we get 10 times 10 is 100. Were you surprised that these came out the same? There's a reason for it. I'll talk about that after I'm finished. If we have one twin, then nothing changes on the girl's side. There's still 5C2. And from the 5 regular boys, we now only get 2 of them. And from the 2 twins, we have to select 1 now. So we get 5C2, which is 10, times 5C2, which is 10, times 2C1, which is 2. So there are 200 committees that have 1 twin on them. 100 no twin committees, 201 twin committees is a grand total of 300 committees that don't have both Peter and Paul. That's it for that one. To the thing here, if you have 5C2, you can think of this as there are 5 people who entered a contest and you're picking 2 of them who win. Essentially, picking 2 people who are going to win a contest is equivalent to picking the 3 people who lost. So if you think of this as 5C2 is picking the winners and 5C3 is picking the losers, of course those are equivalent numbers. You have the same number of choices either way. It's just one of them you're choosing to focus on the 2 who won, and with this one you're choosing to focus on you, and you. You didn't win anything, sorry. But either way, you can choose those the same number of ways. So whenever you have, like, I'll use a different example. If you have 100C2 and 100C98, those will come out the same. This is saying there's 100 people, you're choosing 2 who get goodies. This is saying there's 100 people, pick the 98 who don't get goodies. Those are equivalent. So anytime you have 5 and 3, or 5 and 5 minus 3, for example. And in general, it's NCR and NCN minus R. These 2 combinations are identical. That's like the 100C2 and the 100C98.